Vocabulary, Algebra Triumphs 1.1. Today we will look at the following vocabulary: number line, counting numbers, natural numbers, whole numbers, integers, and opposites. A number line is a line to show where numbers go in order. Negative numbers are on the left, positive numbers are on the right. The arrows on each end show numbers go on forever in both directions. Negative numbers on the left, positive numbers on the right. It's important to note that a number line also shows the size of numbers. Smaller numbers are always left of bigger numbers. The negative numbers are left of the positive numbers, which are on the right. So all negative numbers are smaller than positive numbers. 0 is less than the positive numbers. 0 is smaller than all positive numbers. Here's something interesting though. 0 is to the right of all negative numbers, and 0 is bigger than all negative numbers. We can also tell two numbers, -4 and -1. The smaller number is -4. It is on the left. We can write this by saying -4 is less than -1. Or, since -1 is on the right, it's bigger. We can say -1 is greater than -4. Counting numbers are numbers used to count. They're sometimes called natural numbers. We have a symbol to pay attention to here. These funny brackets mean the set of. The natural numbers are the set of numbers 1, 2, 3, 4, and so on. Natural numbers are another way to say counting numbers. They have the symbol N. Natural numbers are the set 1, 2, 3, 4. Whole numbers are the counting numbers and 0. Whole numbers have the counting numbers 1, 2, 3, 4. They also have 0. The whole numbers and 0. Integers are the whole numbers and their opposites. They have the symbol Z. The whole numbers 0, 1, 2, 3. Those are the whole numbers. Remember, the counting numbers were 1, 2, 3. Whole numbers are the counting numbers 1, 2, 3 plus the number 0. The whole numbers are 0, 1, 2, 3. The opposites then are the opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is -3. The whole numbers are the counting numbers and their opposites. Just like that. Notice the ... on each side. That's the same as our number line arrow. It tells us that our numbers go on forever in both directions. Remember again, curly Q means the set of numbers. Our last term is opposites. Opposites are numbers that are the same distance from 0 on a number line, but in opposite directions. Let's look at +4 and -4. +4 is 4 units to the right of 0. -4 is 4 units to the left. They are both 4 units. They are from 0. They are opposites. Venn diagram is a statement chart. It tells us when things are true together and when they're not. It's important to know if a statement is true, of two things, the circles are going to overlap. If it's always true of one thing and sometimes true of another, it fits inside the one that is sometimes true. If it's never true, the circles are going to never touch. So I want you to pause the video. Create a full-page Venn diagram that looks like the following in your notes. Leave space for examples in each bubble. You should have more space between the bubbles than I do here. That is too little. Stretch it out for the full page. Have enough room to write 1 or 2 sentences in it. Here's what we need to know. If you've got your Venn diagram finished, it's going to be important to follow along. We talked about one type of number first. We talked about counting or natural numbers. Do you remember what those had? Pause the video and look if you don't. Counting or natural numbers are the numbers we use to count. They're the set of numbers. 1, 2, 3, and so on. See how I ran out of room? You shouldn't. Next, we have 0 that we can add. As soon as we add 0 to the counting numbers, we made what? Pause the video and look if you're not sure. We made the whole numbers. The whole numbers are the counting numbers plus 0. What did that look like? Well, that was the set 0, 1, 2, 3, and so on. Notice how the counting numbers fit in the natural number or the whole numbers? That's because the counting numbers and natural numbers are all a type of whole number. But not all whole numbers are counting number. 0 is a whole number. 0 is not a counting number. Once we took the counting numbers and added zeros, we got whole numbers. Once we took the whole numbers and we put in their opposites, we got the integers. The integers are whole numbers and their opposites. So what's that mean? Well, I need to start with the whole numbers, which means I need to start with the counting numbers. 1, 2, 3. Then what did I add? I added 0. Now I have the whole numbers. Now I need to add the opposites. The opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is -3. If I kept going on and on forever in both directions, I would have the integers. Pretty cool, huh? Notice whole numbers fit in integers. All whole numbers are integers, but not all integers are whole numbers. Which integers are not a whole number? If you said -3, -2, -1, or all the negatives, you're right. Those are integers, not whole numbers. Which counting numbers are integers? All of them, because all the counting numbers fit. 1, 2, 3. What number is a whole number but not a counting number? It's the number we added. It's our 0. Finally, we're going to look at 2 more sets of numbers. We didn't talk about these, so we're going to make it quick. Rational numbers. All numbers that can be made into a fraction. Every integer is a rational number. We can put it over 1. But we also have numbers that aren't nice integers. We will talk about those later. One example would be like 23/7. Doesn't make a nice decimal. Another example would be pi. Just kidding. Pi is not a rational number. We can't make it into a fraction. Pi is an irrational number. Irrational numbers are what the Greeks discovered when they tried to make pi. Greeks said, all numbers are nice and rational. We can figure out exactly what they are. Then they found pi, and it freaked them out. So they actually quit doing numbers for about 100 years. What'd they get? Irrational numbers are numbers that cannot be made into a fraction. So, rational numbers and irrational numbers, they're 2 separate bubbles. It is never true that a number is both rational and irrational. The bubbles never cross. This is important. This is the statement up here. The circles never touch. Finally, there's one outer circle, real numbers. All the numbers we're working with are not imaginary. We call them real. Real inventive, huh? All right, quiz time. Copy and answer the following to your notes. Please copy the entire question. Please answer using full sentences. Pause the video and answer. 1. What numbers are not included in the set of counting numbers, but are in the whole numbers? 2. Which part of a number line contains positive numbers? 3. Fix the sentence. Numbers that are the same distance from 0 on a number line are called integers. When you are finished, take a photo and upload it for your note check. How to draw on a number line. To draw on a number line, first thing you got to do is make a line nice and straight. You don't have the technology I have with a smart board. Now, a number line goes in both directions, so we need to make sure that we have arrows. Okay, decide what you're counting by. 1, by 2, by 3, by 5, by 10, by 100. I don't know. Just make sure your spaces are even. I want to draw these about as even as I can. I know it's not going to be 100% perfect if you don't have graph paper. If you need it, I always have it. Okay? Then decide whatever it is you're going to count by. Maybe you're going to count by 2s. And I need to start at 14. 14, 16, 18, 20, and so forth. Be sure to label at least the numbers you need. If you're not sure what you need, be sure to include 0. It's always a good way to make sure you know where 0 is. If you need to know more, you can read more and practice more at the first website. A zoomable number line so you can see how decimals and fractions and everything else work is at the second website. How to read numbers. This 7 in blue is read 7. It's also read positive 7. No sign means positive. Negative 7 is read negative 7. That little dash is subtraction, but when we're looking at the number or the term itself, we read it as a negative. This blue number here is positive 7 or plus 7. If it's in an equation, we might say plus 7. If I want the term itself, it would be positive 7. What do I mean by that? 3 plus 7. Okay. I have two add-ins, 3 and 7. I want to know my terms. My terms are positive 3 and positive 7. I know because I can draw a line in front of my operation to see my different terms. Finally, that red 7 is also read minus 7. If I put it in an equation, I can see that with 3 minus 7. My terms are positive 3 and negative 7. Again, I know this because I draw between my operation and I put the sign with each of them. How to name the opposite of a number. A number is opposite if it switches its sign. 7 can be read as 7 or, remember, positive 7. The opposite of 7 is negative 7. Why? Because 7 is the same as positive 7. Negative 1/2 can be read as negative 1/2. The opposite is positive 1/2, or plus 1/2. Minus 1/2, negative 1/2. Plus 1/2, positive 1/2. So, why don't you try a couple? If I told you that I had 16, is it positive or negative? If you said positive, you're right. I have positive 16. So then, what's the opposite? Well, we flip our sign. Negative 16. What if I started with the number negative 32/5? What's the opposite? Well, first we ask, what's the sign? The sign is currently negative. So the opposite of negative is positive. Then I put the number down, 32/5. 2/5. How to identify sets of numbers, or which sets a number belongs to. Here's what you're going to do. You're going to complete each statement, then determine if a number is or is not part of that set. In your notes, copy this down. I will actually expect you to write this out. It's very important. First, counting numbers are what? Is my number a counting number? Second, whole numbers are what? Is my number a whole number? Third, integers are what? Is my number or is it not an integer? So let's look at a number. I'm going to take the number 3. Okay. Counting numbers are what? Pause the video and go look. Did you find it? Count. 1, 2, 3, 4, 5, 6. All right. What's the number I used? 3. Is 3 in that set of numbers? Yes, it is. So 3 is a counting number. Whole numbers are what? Pause the video and go look. Counting numbers are, or whole numbers, messing it up. Whole numbers are what? Whole numbers are 1, 2, 3, and 0. Whole numbers are the counting numbers plus 0. What's our number? 3. Is 3 in that set? 0, 1, 2, 3, 4, 5, 6. Yes, it is. So 3 is a whole number. Integers are what? Pause your video and go look. Did you find it? Integers are the counting numbers 1, 2, 3. They're the whole numbers 0, 1, 2, 3, and so on. And they're opposites. 0 doesn't have an opposite, but 1's opposite is -1. 2's opposite is -2. 3's opposite is -3. What's our number? 3. Is 3 in the integers going from negative infinity, -3, -2, -1, 0, 1, 2, 3, onto infinity? Yeah, it is. So it is an integer. So 3 is a counting number. It is a whole number. And it's an integer. Let's try it again. What if this time I gave you a negative? I'm going to give you -4. Counting numbers are what? Pause your video and write it in. 0? No. If you said 0, you don't have it right. Counting numbers are what we count. Start counting. 1, 2, 3. Is -4 in that number? 1, 2, 3, 4, 5, 6? No. It is not a counting number. Whole numbers are what? Pause your video and write it in. Whole numbers are counting numbers 1, 2, 3 plus 0. 0, 1, 2, 3, on and on and on. -4, is it in that set? No. So we are not a whole number. What are our integers? Pause it and write it in. 0, 1, 2, 3. Our whole numbers, which include our counting numbers here, also known as natural numbers, and their opposites. -1, -2, -3. And going on and on and on and on and on forever this way. Is -4 in the integers? Well, I have positive numbers, and it's not positive. I have 0, and it's not 0, but I also have every single negative number that doesn't have any fractions or decimals with it. Do I have it? Yes, I do. So -4 is only in the integers. Next, you will have bookwork, and you will be telling me in class if a number fits as a counting number, a natural number, whole number, and integer. Here's something to remember. Counting number and natural number are the same. If you watch this video, you just got a leg up. Good luck.